Hi everyone. This video is going to be about how to fill out 3 circle Venn diagrams for categorical syllogisms to determine validity of arguments. So we'll start with number 2 here. No fossil fuels are renewable forms of energy. Some combustible gases are fossil fuels. Therefore, some combustible gases are not renewable forms of energy. No fossil fuels are renewable. No FRR. Again, you can use whatever letters you want. Just make sure that they're consistent. Some combustible gases are fossil fuels. Some C are F. Middle term here is F. Therefore, some combustible gases are not renewable forms of energy. Some C are not R. Major term R happens in the first premise. Minor term C in the second premise, and middle term F. The middle term is the one that appears twice, once in each premise above the conclusion. So if we we create our circles, and then the minor term on the left, major term on the right, middle term in the center circle, and we will then shade and or mark with X's our premises only. Remember, you don't shade the conclusion. You see if the conclusion follows logically from the premises shading. So no F or R. So in order to shade an E-form statement, we look at the F circle and the R circle. We forget the C circle. Remember, when you shade, you create emptiness. You create nothingness. So if no F's or R's, then we need to shade the middle between the F and the R circles so that the only F's that exist are out here. Now the F's here are C's, and the F's in this region are just F's. But notice that there are no F's that are R's. Okay, so no F or R, some C are F. Okay, so remember, with a particular statement, you place an X. So if some C's are F's, we look at these two circles, then we would know the only places where C's are F's occur here. But this region is empty, right, because it's shaded. So the only place where C's can be F's would be right here. And so we place our X in the open space between C and F. So no F's are R's, and some C's are F's. And the X means at least one C, and it's placed there. So now we need to look at this and determine whether the conclusion follows logically. The conclusion here is some C's are not R's. Some C are not R. Does that follow from this shading? Are there C's that exist that are not R's? Yes, there's one right here, and it's outside of the R circle, but it's within the C circle. So this is logically valid from the Boolean perspective, and hence, therefore, from the Aristotelian perspective. That was number 2. Number 3, no individuals truly concerned with the plight of suffering humanity are people motivated primarily by self-interest. Concerned. No concerned individuals are individuals motivated by self-interest. All television evangelists are people motivated by self-interest. All T are people motivated by self-interest. Therefore, some television evangelists are not individuals concerned with the plight of the suffering of humanity. Some televangelists are not concerned people. So it's an EAO. Remember, when the middle term is stacked on the right, that's form 2. So this is an EAO form 2. You can check that in the table. But we're, again, using Venn diagrams to determine validity. So remember that you always shade universal statements first. And in this case, both of these are universal. E statement, so it doesn't matter which one you shade, but we can just start from the top. No CRM. Okay, so remember, the middle term is the middle circle, the major term is the bottom right circle, and the minor term is the bottom left circle. So no CRM. All right, so here's our C circle, here's our M circle. In order for none of the C's to be M's, we have to shade in the regions where the C and the M circles intersect. Again, remember, when you shade, you are not indicating where things are, you are creating emptiness. you're showing where things are not. So no CRM, here we go, no CRM now. Next, all T are M. So now we focus on the T circle and the M circle. We already have no C or M shaded. Remember, for a universal A form statement, all T are M. That means the only T's that exist would be within the region where the T and the M circles intersect. All T are M. And so when we shade, we create emptiness. So we have to shade outside of that region because there aren't any T's that exist that are not M's. Or another way to say it, there are no T's outside of the M circle. There are no T's out here. So we need to shade that circle. So the only region we have left is this region. Okay, we have a particular conclusion, some T are not C. And so we need to see some T are not C. Does that follow here? It doesn't, right? Because for a T not to be a C, we would need an X in this region. Now, that's from the Boolean perspective. So this is not considered to be a logically valid form from the Boolean perspective universally. But we're supposed to check from the Boolean and the Aristotelian. So from the Aristotelian perspective, if you have a circle with only one region open, which we do, we have the T circle, the televangelist circle is open, and only one region of that whole circle is open, then what you do is you add an X and you circle it to indicate that you've added it, and that's why it's different from the non-circled X. And then, so that's what we do first, and then we have to check to see if the things that are represented by this circle actually exist. If they do, then this would be logically valid from the Aristotelian viewpoint only. So do televangelists exist? Yes, they do. And so this argument, the syllogism, is not valid from the Boolean perspective, but it is valid from the Aristotelian perspective. And on a side note, there are no categorical syllogisms that are valid from the Boolean perspective that have universal premises and a particular conclusion. In order for them to be valid from the Boolean perspective, a particular conclusion requires one and only one particular premise. And that comes from the rules. But again, so I'm talking about all the different ways we can evaluate these. We can use the table. We can use the rules for evaluating syllogisms. That'll come, I think, in a future section of this book. And we can also use the Venn diagrams that we're using here. Okay, let's do one more. This is number 6. All impulse buyers are consumers with credit cards. All impulse buyers are consumers with credit cards. C. All shopaholics are impulse buyers. All S are I. Middle term, form 1. When it's angled down that way, it's form 1. And then finally, therefore, all shopaholics are consumers with credit cards. All shopaholics are consumers with credit cards. Major term has to be in the first premise. Minor term should be in the second premise. Middle term is the double term that occurs within the premises themselves. So I is our middle term, C is our major term, S is our minor term. This is an AAA form 1 syllogism. Now, this is probably the easiest one to memorize, but AAA1 is a logical form. AAA1, pretty easy to remember, AAA1, logical form, so, or logically valid form, sorry. But anyway, we're supposed to complete this by using Venn diagrams, so let's do that. Remember, always shade your universal premises first. In this case, we have 2 universal premises. All I are C, so we focus on the I circle and the C circle. The only I's that can exist must be C's, so that is this area where they overlap, the I and C circles. When you shade an A-form statement, you have to shade outside of that overlapping area to empty it, to make it to make nothing exist there. And so now the only I's that exist are in the C circle. All S are I. So now we have to think about shading all S's are I's. Well, the only region where S's are I's that's still open is this region. This whole region would be the entire region, but this portion is already empty. So we're going to need to shade all of this around here, the S circle that aren't I's. So when we do that, we end up with this form. So you can see the only S's that exist now are I's. There cannot be any S's that are C's or S's that are just S's. And then we don't shade the conclusion. All S are C. Does that logically follow from this? Are all the S's that exist C's? The answer is yes. So this is a logically valid syllogism. All of these S's that are in here are C's. Now there are also I's too. And logically that is fine. It's okay to be an S that's a C that's an I, or an S that's an I that's a C, and say all S's are I's, all S's are C's, because that's true. And in this case, it's all S's are C's. It's an AA1 mood and figure categorical syllogism. And so we know already that it's logically valid, and our Venn diagram has proven that it is logically valid. All right, lots of stuff there. I know I moved pretty quickly, but try to make these videos as fast as possible. So anyway, I hope that this helps you understand categorical syllogisms and how to use three-circle Venn diagrams to test for validity, both from the Boolean and Aristotelian standpoints.